And it does pick literally everything up. So
Sound wise?
oh yeah.
Yeah. Were you were messing with it on your computer too?
No, just listening to the feed.
Yeah. Again, I'm almost positive that it is not only picking up the sound from the microphone on the.
Go ahead and switch up the screen and see. Is that good? We zoomed it in last time. That's what we did.
Here we go. I hope they work.
Oh yeah, I have black ones too. Is that? I forgot to bring those. Oh yeah, just make sure that we're not going to lose anything when we like go to the next slide.
I'm so glad you guys know what you're doing.
You good with that? I'm good with that.
Yeah.
It keeps wanting to shift because of the cord.
I mean that's fine. You can see it's plenty big.
And I can put some tape down if we're concerned about that.
Yeah.
But putting some tape down may result in having to reapply it every single time.
Correct.
You got people?
Yep.
So we're expecting a big crowd of about 50 to 60 people today. Well, I'm going to leave it up to you guys for the first hour. And then once we're done with this live stream, then Daddy's going to check and see where you guys are at. Okay? Now, don't feel like Daddy's trying to get you guys in trouble for checking up on it. It's just we need to make sure that you're on pace and that you are doing what you're supposed to be doing. Does that make sense, Elsie? So you're not in trouble if you don't get something done.
Gene, would you mind doing the live chat for this one? Are you gonna follow along? Or are you gonna watch
Yeah.
something
So you want me? Yeah, no. Can I watch from
Well,
here?
else? No, you can do it over there. Well, they were just saying that they could hear the like clicking of the typing was a little bit annoying in the last videos.
Oh, gotcha.
They were picking it up from this computer. They could hear the clicking.
I could definitely do that. So you want me to like type the questions?
Just type the questions in there.
So the two things that they asked us to work on was the picture. So we moved the webcam up more. And it was the clicking noise. It keeps moving, doesn't it? That cord.
It's definitely the cord. When the cord straightens out, I mean that's pretty good.
Okay, that's fine. What we got? How many people? Okay,
We got 11.
So still
Well,
not.
I mean, and we still have.
So guys, remember that once you guys are in the live chat, make sure to put down your name and also your teacher, so which class you belong to. Thank you guys. Can't wait for this amazing PowerPoint. I'm excited.
Okay, I'm not seeing the live.
Let me check.
That is live out there.
I'm checking right now.
I'm going to embed a.
It should. So you go to my channel.
Uh-huh.
I need to embed a white screen.
What
I don't know why it does that.
I need to embed a white screen. Be right back. For the conversions. So that whenever we work them out for them or help them work it out.
We got a bunch, 21 now. Sweet.
Hey, it's Mr. Ewald here, guys. While Mr. Wynn is working on getting everything set up on his end, just a quick reminder, make sure that you have something to write with. It can be a notebook, it can be a binder, you can be doing it on the notes feature on your computer, but just make sure you're following along with the notes, the discussion that we're having. Make sure you have that stuff for yourself so that when this is all done, you have that, okay? Also, make sure you put your name and your teacher's name in the live chat. Just like we did last week, Mrs. Becker today is going to be throwing out some questions in the live chat, so make sure that we're trying our best to participate with that and kind of follow along with us. We're super excited. Second live lecture for you guys, so let's get it going. Mr. Wynn will be back with you here in just a second.
Twenty. 24,
Okay.
and we got a bunch that are signing in.
Okay. So we need to start at 8:10. If we want to finish this, we have to start at 8:10.
And make sure that we give them the time that they need to work. So I'm just gonna look at YouTube.
I'm going to introduce the group project today after everything's said and done.
Have you posted any of that stuff yet?
No.
So you're just gonna tell them about it, and then we'll communicate with them.
Correct. During the small group chat,
Yeah.
that's whenever we'll. So they're going to have the metric system worksheet today,
Yes.
and then over the course of those 2 days, that's whenever I'm going to introduce the small
Okay,
group.
I'm down with that because I also posted the metric system practice for them to work on after this, so it'll be good.
There is a assessment part of it. I don't know if you saw that or not. There's an assessment part where if you have them submit the answers into the assessment part, they can find out whether they have the answers right or not.
Okay.
So it's real simple, real easy. They get an instantaneous idea of whether they understand it or not. So
Like it. I said we'll give it like 30 more seconds, maybe a minute. I'll keep an eye on this stuff like we did.
Okay.
And then obviously I'll help you with turning
Sure.
the camera and doing all that stuff.
Did you hurt your nose?
I did.
I didn't know whether or not you're using it so that it stays in place.
Well, it's in the perfect spot where this nose thing rubs on it. So that's why I have to have. Normally I wouldn't wear a Band-Aid, but I just have a little thing on my nose that the mask rubs on. So I have to look like a goofball with my Band-Aid, big Band-Aid on my nose.
What's better, this side or the other side? I think this side's better actually, because then I don't have to keep crossing the streams.
Yeah, and then you can just reset.
One more minute, guys, and then we will get started. Good morning, by the way. Thank you for joining us.
I also noticed. Remember how the camera got really like laggy when you when somebody was typing on this computer? That's always when the feed would lag. So if we're using a separate computer for the typing,
Then it
then
may not
hopefully
lag
we
as
won't
much.
see that lag. It'll be just a continuous feed, and we won't have any of that stuff. Or it won't get as bad, like 30 seconds.
So we're going to go ahead and get started. So make sure, again, that you have a sheet of paper out, something to write with, and that way, whenever you are done with this particular live lecture, you can turn it in the way that your teacher wants you to turn it in. So make sure you have something to write with, something to write on. Make sure you're paying attention. Make sure that you are participating. So hopefully we have a lot of people that already know about the metric system, but if you don't, that's okay. We hope to enlighten you guys.
It's a little big.
So in terms of the metric system was developed in the late 1700s by the French, and it was based on a power of 10. And the reason why that's so important is because that power of 10 makes it very, very easy to be able to convert from one unit to the other. So it's used by almost every single country except for the United States. We're still using the imperial system. So it really doesn't make much sense as to why we haven't transitioned yet, except for the fact that we're used to our own system. It's especially used in the scientific community, and it's abbreviated as the SI unit of measurement. And so you might hear that from time to time and wonder, what the heck is SI? Well, SI is the metric system that we're talking about. So some metric prefixes that are going to be very, very common are going to be kilo, centi, and milli that you're going to hear quite a bit throughout the entire year. So we want to make sure that we understand what these prefixes mean and how they're related to one another. So if you have the metric system and it's based off of a base of 10, it makes it very, very easy to be able to convert from meters to centimeters to milliliters. So that 1 meter is equal to 100 centimeters, and 1 meter is also equal to 1,000 millimeters. So it makes it very, very easy using that system of 10. Now, we have also some base units as well. So your meter, your liter, and your gram. And this chart may look really complicated, but actually it's not. So it starts from the top, where the top is the largest, and then from the bottom you have milli, micro, and nano, which are going to be really, really small. We are not going to have you guys memorize this, okay? So any type of assessment that you encounter, we're going to give you this chart. It's not necessary in order for you guys to memorize it, okay? There are different types of mnemonic devices in order to remember the different units, but again, it's not really necessary. Now, that base unit occurs here, by the way, guys, okay? That base unit occurs here. And what a lot of students really, really get confused about is the meter and the millimeter. So really you want to make sure to clarify that. The meter is just a single M. A millimeter is 2 M's. Also, something that students really get confused about is deca and deci. Deca is DA. Deci is just a single D. So whenever we start using these prefixes and you're referring back to this chart, you want to make sure that there are some things that are going to be a little bit confusing, so you want to make sure to clear that up. First thing that we're definitely going to encounter this year is going to be length and being able to measure 2 different points. So the SI unit for length, the SI base unit for length is meter. So we're going to use a ruler in order to make sure that we understand what the different lengths are. So your first question that I want you to write down on a separate sheet of paper, and again, you don't have to write down the question, you just have to write the answer down. What would be the appropriate unit of length for measuring the following if you're using kilometer, meter, centimeter, or millimeter? Okay, so we have 4 different scenarios: the thickness of your fingernail, distance between your house and HHS, the height of the roof of your house, and the length of your foot. Okay, so in this case, I want you to give me what you think is the appropriate measurement. So A, B, C, and then D. Okay, so whatever those units are. I'm going to give you guys about a minute to 2 minutes to think about this. And once you have the answers down, let's hear from A through L. Okay, A through L. Start throwing out those answers for A, B, C, and D.
It's actually better than it was. The ease of seeing the screen is much better.
All right, here we go.
Yep.
So we have, we do have an answer coming in. So we have for the thickness of the fingernail, millimeter. Distance between your house and Highlands High School, kilometer or kilometer. The height of the roof of your house, we had meter. And then the length of your foot, we had centimeter.
Awesome job, guys. That is 100% correct. Okay, so good job on that. Again, in terms of making sure to add this to your notes, make sure to do that. And we want to really get an idea of what each one of these different types of lengths of measurement really try to measure and the differences that they measure. Because again, it would not be appropriate if you had the thickness of your fingernail being a kilometer. That would be really, really scary. So you want to make sure that you use your appropriate unit of length. Now we're going to do a live demonstration, so making sure that we're able to use a ruler in order to measure different types of items. Now it should be pretty obvious how to use a ruler, but again, it's just making sure that everybody's on the same page and we know how and what to expect in terms of measuring length. So we're going to measure an iPhone, the height of the cup, and the diameter of the tape.
All right, so here we go, guys. I'm going to turn the camera around so that you can see what Mr. Wen is doing. Okay, so here he has the ruler, and he has his iPhone. I'm trying to get it to where it is focusing really well. And you can see that pretty well. Mr. Wen will tell you a little bit about what he's seen on his end, and we can go from there.
Okay, so what we have is we have an iPhone with a plastic cover, and we want to make sure that we measure the length. And so what we're looking at here is at the very end of this particular iPhone, so it's right at the end of my finger there. So if you can read off that number and put it into chat, let's go ahead and do that. Okay, so let's do this for everybody. So everybody, if you could tell me what the length of my iPhone is with a clear case, then go ahead and write that in chat.
Nobody's responding yet.
It'll take us just a minute to get there. You can see that it's. Oh, there we go.
All right, we've got 15.5 centimeters. 15 centimeters, 15 centimeters, 16 centimeters, 15.3, 15.5, 15, 15, 15.5, 15.
So the case was the tricky part to see like what the actual end of the case was. We got lunch. Simon, we're good to go. Tons.
Okay, so the actual length of the iPhone with the clear case was 15.8. Okay, so 15.8. So if you were at 16, that was really, really close. So good job on that. Okay. All right, we're going to do the height of the cup next. Okay, so height of the cup. So there's a couple ways you can do this. You can put it side by side, but what I would like to do is actually put it in front. Okay, because putting it in front ensures that there's no bias whatsoever in how you place it side by side. Okay, so why don't you go ahead and look at that and then tell me what is the length of the height of the cup.
And again, we know that the image is not perfectly clear, but what you can see there is that right near the lip of the cup we have 10, and then we have some little tick marks after that. So your best estimate, what do you think from that one?
Alrighty, guys. So again,
Ten.
if
Got
you
10 centimeters.
go ahead and put down in chat what you think it is.
We've got 10.2 centimeters. We've got a couple that are forgetting their units. Folks, always write your units in. 10 centimeters, 10 centimeters. We've got 10 centimeters, 10.2.
And so we want to make sure that we're very, very clear about the ruler and how to read a ruler. So every single one of those small little tick marks is a 1 millimeter, because the larger numbers is a centimeter. So if you're reading off of a large number, then you're reading a centimeter. If you're reading off of a smaller tick, then it is a millimeter. So you're going to have something along the lines of 10.1, 10.2, 10.3, something along those lines, if it's on that small tick mark. Okay? Now, the actual height of that cup is 10.1. Okay, so 10.1. So if you have that, good job. If again, it's hard to see because of the webcam, not a big deal. We're going to get a lot more practice once we come back. All right, and the last one.
Yeah. And again, you guys are right on there. Like, we didn't have anybody that put 15 for the height of the cup or 20, right? Everybody was right on with 10, 10.1, 10.2, 10.3. So fantastic job. So we're going to try to maybe get a little bit closer here and see if we can find the diameter of the tape that Mr. Wen has here. And again, it's not perfect, but we see the 10, we see the 11, and we see the 12. Those are our centimeter marks. So we just have to try to estimate about where we think we are within that range.
Make sure to put that in chat, everybody.
All right.
That's good, Mr. Ewald.
That was a little better? Okay. The focusing is the struggle with getting right in on those numbers. So.
Sometimes you have to pull that on the.
All right, we've got answers coming in. 11.4 centimeters, 11.4, 11.5, 11.4. Folks, remember, put your units in. A lot of people were just saying numbers without the units. 11.4 centimeters.
Fantastic job, guys. 11.4, 11.5. I would accept both those answers. Okay, so good job on that. And we're going to come back to the PowerPoint and making sure that we talk about our next SI unit that we're going to encounter in biology.
So back to Mr. Wen.
Now, what we just did was precision and accuracy. So a lot of you guys were precise in terms of the exactness of your measurement. A lot of you guys were accurate in terms of how close the measurement was to the true value. So we're going to talk about what the difference is between precision and accuracy is. Okay? So we're going to talk about with an example. So in terms of Highlands is in Fort Thomas, that is 100% accurate. But it's not exact. So if you tell somebody, hey, you know what, go to Fort Thomas, you'll find Highlands. That's not going to be very helpful for them. They're going to be wandering all over the place. Highlands is at 15 North Fort Thomas Avenue. That's precise. Absolutely 100%. 15 North Fort Thomas. We can walk there. I'm sure that we can take a picture there. But it's not accurate because that's not where Highlands High School is. So you can be precise but not accurate. Highlands is at 2400 Memorial Parkway, Fort Thomas, Kentucky. That is both precise and accurate. Okay, so in terms of making sure that you're precise and accurate, in science we want both. We want to be able to be precise and accurate because our experiments need to be replicated by other people, and we also want to make sure that what we're actually testing is accurate. Our next characteristic that we're going to talk about is mass. So mass is the amount of matter that an object has.
So I'm sure that you guys remember this from physics and the fact that mass and weight are interrelated, but they're not the same. So that in terms of a golf ball and a ping pong ball, they're about the same size. Okay, but we do know that a golf ball has a lot more matter, so it has a lot more mass. Now, the SI base unit for mass is the gram. So, a paperclip is about the mass of 1 gram. So, the mass of an object will not change, okay, unless we do something to the object where we break it apart, we cut it in half, whatever the case may be. But the mass of an object will not change even if you take it to outer space, okay? So the weight of an object will change, but not the mass of an object. So how do we measure mass in biology? Well, we use a triple beam balance. And we're going to show you guys a triple beam balance here in just a second, and making sure that we understand how to read it. But first, before we do that, we want to, again, think about these appropriate units of mass and making sure that we're able to apply them appropriately. So we have 3 different types of units of mass. We have kilogram, we have gram, and we have milligram. So, amount of vitamin A in an energy bar. Will we measure it in kilograms, grams, or milligrams? Mass of a bowling ball, kilogram, gram, or milligram. And then mass of a mouse, kilogram, gram, or milligram. Right, so make sure, everybody, to go ahead and put in your answers in question number 3 in order to make sure that we understand that there are different units of mass and that some of them are more appropriate to use in certain instances than others. Okay, so let's take about a minute to 2 minutes to think about that.
All right, we're getting some answers in the live chat. For A was amount of vitamin A in an energy bar. B was mass of a bowling ball. C was mass of a mouse. So our first one is for measuring the amount of vitamin A, milligram. For measuring the mass of a bowling ball, kilogram. And for measuring the mass of a mouse, gram. And then the very next one was milligram, kilogram, and gram. So we're so far spot on.
All right.
So far, so good.
Good job, guys, in terms of the units of mass. And again, make sure to add this to your notes that you are going to turn into your teachers, okay? So I know that there was a little bit of confusion in terms of what to turn in.
And Mr. Wen mentioned something a little bit earlier in the lecture, and I think that if you didn't already have it, you're probably seeing it right now. Remember, he showed that chart at the very beginning where at the very top was mega and at the bottom was milli, right? Mega and kilogram, those are larger than grams or meters, right? Which are larger than things like centimeters or centigrams or millimeters or milligrams. So you guys are definitely grabbing onto kilogram is the largest, and then we had gram, which was in the middle, and then we had milligram, which was the smallest. So keep that up. Awesome, awesome, awesome. Yeah, milligram, kilogram, gram. So we're doing great there.
Alrighty, now, so this is a picture of a triple beam balance, and we want to make sure that everyone understands how to read a triple beam balance. So on the first line is your ones. On your second line is your hundreds, and then your last line is your tens. So in order to make sure that we're calculating this properly, we want to make sure that we're using a triple beam balance using the appropriate units of measure. So we're always going to start with the largest one first. Okay, so in terms of the hundreds, you're going to start in the middle. Then afterwards, you're going to start in the back. And then your very last one is going to be that ones. And we want to make sure that we're able to do that. Now I'm going to show you a couple of examples on the live demonstration, but in the chat, what I would like you to do is tell me how much mass is on this triple beam balance example.
Oh, here we go. We got our first couple of answers. We have 37.3 grams, 37.3 grams, 37.3 grams, 37.3 grams. Bam, bam, bam. Lots of 37.3 grams.
All right, guys, excellent job. It is 37.3 grams. You're absolutely 100% right. Okay, so again, being able to read this and being able to manipulate a triple beam balance is a little bit different, so we want to make sure that we show you some practice on that. So our live demonstration is going to be on the same three items. Okay, so iPhone, plastic cup, and masking tape. We're going to find out what the mass is for each one of these. Okay, so like I said before, this is the ones, this is the hundreds, and this is the tens. So that whenever I put my phone down, I'm going to just start. I'm just gonna just go, right? Just go.
Yeah, that's probably not the best way to do it, Mr. White.
Oh, okay, wait. Mr. Ewald, what am I supposed to start with?
The very first one that you're supposed to start with is the hundreds in the middle.
I totally forgot. Okay, so I'm going to start with the hundreds, and I'm going to make sure to move it to where it's slotted and it can't move. Okay, you can also see that the arrow is right above the number. It's really important for students to remember that because a lot of the times what ends up happening is that students, they have it right in the middle, and that's not going to read anything. Okay, so then I'm going to keep moving because it hasn't gone down yet. I'm going to keep moving. Hasn't gone down yet. And right there. Okay, Mr. Ewald, can you get a shot of that real quick? So you can see that it's moved down, which means that it's too heavy. So we want to make sure to move back one, and then we're going to start with the tens next. Okay, so we're going to do the same exact thing. And we're just going to keep moving it until it starts to move down. Oh, it is moving quite a bit. Okay, and one more. All right, so that one's down now. So then we're going to move back one. And then we're going to use this last one to make sure to zero it out.
So let's show them really quickly. So over here, this is going to show us that we have the correct mass reading on the triple beam balance. So when this line, and I know it's kind of hard, when this line right here lines up with where the zero is, that's going to show us that we have the correct mass reading. So we are really close. So Mr. Wen's going to move it just a little bit here to see if he can.
Just a little bit. Just a little. Ooh, even that little bit. Okay, so I think that's good. Now we're going to go ahead and focus on those numbers. And in the chat, why don't you guys go ahead and tell me what that number is for the mass of the iPhone. Okay, so what is the mass of the iPhone?
So the middle is right there. You can see that. The back one is on there. All right. And then our front are our ones. Try to zoom in on that. It's right there.
So we have our middle, we have our back, we have our front. Okay, so throw those in the chat, see what you can come up with. Cool, we got a couple. You want me to go ahead and read those off right now, Mr. Wen?
Absolutely. Let's hear it.
Okay, so we have 250.3, 250.3, 250.4, 250.3, 250.4. So looks like the majority of us are right at 250.3 grams and 250.4 grams.
All right, great job, guys. Okay, 250.3, 250.4, really, really close in numbers. So I would be very, very happy if you got within that range. All right, so our next item is going to be the cup. Okay. All right. So again, we're going to start with the middle. Although I'm pretty sure that the cup is not 100 grams. Okay, I was right. It is not 100 grams. Okay, so then I'm going to move to the tens. Ooh, it's not even 10 grams. So now we're just going to use the ones. Okay.
So what Mr. Wen is doing is he's moving the ones, but he's also looking over here to see where our two lines are with lining up. Remember, we want to have those together, and that's going to tell us that we have the correct measure for the mass. So we'll give it a second to kind of even out a little bit. All right, so here's our middle. Okay, we can see where that is. Here's our back. You can see where that is. And then our ones up here in the front. And again, it's not focusing great, but you can see that that's where our ones is, or ones are. So based on what you see there, again, my apologies for the focus. Based on what you see there, what do you think the mass of the plastic cup is? Go ahead and throw that into the chat.
We've got a 7.6, 7.6, 7.6 grams, 7.6, 7.6 grams.
Love it.
Now everybody with the iPhone remembered their units, but not everybody with the cup are remembering to put in their units.
So remember.
7.6 grams.
As Ms. Becker has said a couple of times, we have to make sure that we have those units on there. Because if you just say 7.6, we don't know if you're saying 7.6 meters, 7.6 kilograms. We want to make sure that we have those correct units so we know exactly what you're talking about.
All right, and the last one's going to be the masking tape. Okay, so again, the masking tape, we always start out in the middle. We always want to make sure that it's not 100 grams. Okay, then we're going to move to the tenths. Okay, and the last one is going to be the ones. So in terms of the tens, if I moved it, it went straight down, so we want to make sure to use this now. Okay, so we need to move it back just a little bit.
Okay, so you can see that our lines are lined up pretty well. So we have our middle right here. Okay, sorry for the shakiness. We have our back right there. And then our measurement in the front. And I'm going to try to get close in there so you guys can see it. So there's our measurement for the front. Okay, middle, back, front. And what you can see is that our lines over here are lined up. Okay, so we're happy with that measurement. Okay? Throw that into the chat. What do you think the mass of the tape is, make sure you put your units in there.
Alright, we have 100.2, 100.1 grams, 100.2 grams, 100.1 grams, 100.1 gram.
Beautiful. Beautiful.
Alrighty, guys, good job on that. Okay, so that's the triple beam balance and making sure that we use a triple beam balance in order to calculate mass. Okay, so we want to make sure again that we use our appropriate units, and we also make sure that we're using our appropriate tools as well. So our last SI unit that we're going to talk about is volume. And so volume is the amount of space an object takes up. So it's a very, very easy way to calculate volume if you have a fairly regular shape. So let's take, for example, the box shape. If you have a box, you calculate the volume by multiplying the length times the width times the height. Fairly simple. Okay? But we also know that not all things are going to follow that box shape. So we want to make sure that in terms of whatever shape we're looking at, that we utilize that appropriate equation. In this case, the units would be cubic centimeters as well, okay? So that if we're multiplying or we're looking at these different sides, we're looking at centimeters, and we want to make sure that we're very, very clear about our units. Now, what we use in order to measure volume is a graduated cylinder. So that the base unit for volume is going to be your liter. So again, if we're remembering that chart, we're looking right at that middle line there. Okay, so we're looking at liters. So we're going to measure volume using a graduated cylinder. We're going to have 4 different examples to show you. Now, important thing to note about a graduated cylinder is that it's going to have these curved lines. And that curved line makes it a little bit difficult to be able to determine what that volume is, unless you read the very bottom. The very bottom is called a meniscus, and what ends up happening is that that water is attracted to the sides of the glass of that particular graduated cylinder. And so that's why it has that curve through adhesive forces. So in terms of the meniscus, you're looking at the very bottom of the graduated cylinder in order to determine volume. Alrighty guys, so real quick, just make sure that we understand what we're looking at. So go ahead and chat, tell us what the volume of this particular graduated cylinder would be, and let's say that this is milliliters, okay? So if we're looking at a graduated cylinder that is measured in milliliters, go ahead and tell us what that volume is going to be.
Now I'm going to jump in here really quickly, guys, just to make sure that we're all on the same page. If we're looking at the graduated cylinder, all right, so this is a zoomed-in image of our graduated cylinder. Here we have 40. Here we have 50. What we want to look at is how many individual tick marks do we have between 40 and 50, because that's going to allow us to find the actual measure for the volume. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tick marks in between 40 and 50. So use that knowledge and see if you can come up with that appropriate measure for the volume of the liquid in the graduated cylinder. All right, throw that into the live chat and then we'll go from there.
We've got 43 mils, 43 millimeters. We have 40.3 milliliters. We've got milliliters, millimeters, 43 milliliters,
Okay,
milliliters.
so good job guys. It is 43 milliliters, and we want to make sure that we understand how to calculate and that we know that each one of these tick marks are going up by 1. An easy way to do that is to take this number, and subtract them. So that 50 minus 40 is 10. We know that there are 10 tick marks, so each one of them has to be worth 1 milliliter.
I kind of jumped the gun there. Sorry, Mr. Wen.
All right, so in terms of the live demonstration for the volume, graduated cylinder number 1, graduated cylinder number 2, number 3, and number 4. We're going to show you some graduated cylinders so that you have an opportunity to make sure that you're able to calculate the volume. Again, add this to your sheet of paper so that we are on question number 5 now. So the one on the left is going to be your graduated cylinder number 1.
Right here?
The one on your right is going to be graduated cylinder number 2.
Right there?
I could even turn this way. All right, take a few minutes to think about what that's going to be. This is like GoPro.
It is.
GoPro in biology.
Trying to find that perfect spot to where it's focused, you can see it. So remember, we're looking for those large values. So on the left, we have our liquid is in between 6 and 7. So we want to try our best to see if we can see how many of those individual tick marks are in between the 6 and the 7. And that's going to help us get closer to the actual value. So let's see if we have any coming in for graduated cylinders number 1 and 2. Remember, 1 is on the left, 2 is on the right.
Now, we also know that that particular volume comes in between 7 and 6. So what that means is that the answer can't be below 6, and the answer can't be above 7. So you want to make sure that you take all of the different types of numbers and really use them as a way to your advantage to try to figure out what that volume is going to be. Same way with the one on the right, you know the answer has to be between 20 and 15. It cannot be above 20, can't be below 15. Alrighty, guys, we're going to move on to number 3 and 4. Okay, so we want to make sure that we have enough time to be able to go through the PowerPoint. So this is going to be graduated cylinders 3 here.
Right here. Graduated cylinder number 3.
And 4 here.
Graduated cylinder number 4 is right over here.
And you can see that these are so much easier to see. Okay, so we got 2 here. So numbers 3 and 4. Okay. So give you guys about 30 seconds to think about what that volume is, and then we'll go over all the answers to make sure we read them correctly.
And again, imagine that you're seeing these with your own eyes in the lab, in class. It's going to be a lot easier to read. I think Mr. Wen has done a great job here with setting these up for you guys. It's not perfect, but we can at least do a little bit of practice through the computer to see kind of how this works. And great job with those answers in the live chat. So we have a lot of people that are bringing those in. We have the answers for 1 and 2. We are starting just now to get some answers for 3 and 4. So while Mr. Wen kind of finishes up his part over here, we'll take a look at those answers that you guys are throwing into the live chat, and then we'll share those out. Awesome, awesome job with the participation, guys. You're right on it. So, Mr. Wen, for graduated cylinders 1 and 3,
what we have a lot right around 6.7, 6.8. We did have a 6.6 milliliters for graduated cylinder number 1.
Alrighty. And
For
you,
number- I'm sorry, for number 2, we had 18 mils.
okay. You guys are doing a fantastic
For
job.
graduated cylinder number 3, we've got 47 mils. And for graduated cylinder number 4, we have 52 mils. What do you think, Mr. Wynn?
I think they did a fantastic job. So in graduated cylinder number 1, it was 6.6 milliliters. So good job on that. Graduated cylinder number 2 is 18 milliliters. Graduated number 3 is 42 milliliters. I'm sorry, 47 milliliters. And graduated number 4 is 52 milliliters. So again, good job, guys. We want to make sure to give you guys enough practice to make sure that we're able to read the graduated cylinders.
Yeah, awesome work, guys.
Yep, answers are great.
Wonderful.
They're using units. They're good.
Okay, just a little fun fact. 1 milliliter is equal to 1 cubic centimeter, and generally speaking, the cubic centimeter is your SI unit of volume as well as the liter. So, kind of what we talked about already, the meter, the gram, the liter, length, mass, and volume. What we're not going to get to, and hopefully everyone understands this, is going to be temperature and time. Okay, so in terms of temperature, Celsius or Kelvin is what we utilize in science. Generally speaking, with physics, we're going to use Kelvin, and biology, generally, it's going to be Celsius. And then in terms of time, it's going to be seconds. And then, again, we don't use the Celsius scale, but if you're kind of thinking, okay, what would Celsius look like in our world? 30 is hot, 20 is nice, 10 is chilly, 0 is ice. Whereas we use the 212 Fahrenheit, the 32 degree Fahrenheit scale, which tells us, okay, water freezes at 32 and it boils at 212. Okay, why they came up with those numbers, no idea, but that's what we use. Now, the last part of this lecture deals with those conversions. So we talked about those conversions being a base 10. So we want to make sure that we get some practice with being able to convert from one unit to the next. So what I would like you to do is go ahead and write these down. Okay, so if they're kind of hard to see, we want to make sure that we go ahead and tell you guys what those are. So 422 centimeters, 69.63 liters, 9.23 grams, 6,523 millimeters, 13 deciliters, and 230 milligrams. So what you're going to do is you're going to convert from centimeter to meter. Now, we'll go ahead and go over the first one just to make sure everybody kind of understands how to utilize this scale. Okay, so if you have centimeters, we're going to find centimeters up here. Okay, centimeter. Oh, okay, there it is. All right, there's centimeters. And we're going to go to meters, okay? Oh, here's an M, so we're going to go here, right?
No.
Oh, what's this?
So if we remember, when we're thinking about how large and small these units are, if we find centimeters, which is what Mr. Wen just found before, the C, we know that millimeter is actually smaller than a centimeter. So that M right next to the C, because that's a smaller unit, that's actually going to be our millimeter. So you're going to have to look somewhere else to find the other M.
Okay. So I'm going to find the other M. There's another M.
Oh, yeah.
Okay, so we're going to go to this M instead because that's bigger. And so centi to meter, how many times did I go over from centi to meter? Well, 1, 2, so I went over twice. And so all we're going to have to do is we're going to move the decimal to the left. Okay, how many times? Twice. Okay, so in order to do that,
we know that the decimal is located here. So all we're going to do is move it over twice. 1, 2. So that our answer is going to be 4.22 meters. Alrighty, guys. Give the other ones a shot. We're going to give you about 3 to 5 minutes to think about each one of the rest of those, and then we'll go over the answers to make sure we understand what's going on.
So we have 15 minutes, Mr. White.
Alrighty, guys. So just for the convenience of time, because I know that I'm sure that you guys are thinking, wow, 8:05 was really, really early. When is this live lecture going to be done? We're going to go through the answers real quick just to make sure we have the correct ones. Okay, so there you go. There are the correct answers for yours. You're more than welcome to add it to your notes. You're going to have practice on this, whether you're in my class, Mr. Ewald's class, or Ms. Becker's class. You're going to have practice on this, so we definitely want to make sure that you understand how to do this. And if you don't understand how to do this, we can always talk to you guys in that small setting, that small group setting, whenever you guys have questions about that. Okay, so the last thing is going to be about converting if there isn't a factor of 10. So let's use money, because everybody understands money really well. We want more money. Okay, so let's say, for instance, we had 22 quarters, 7 dimes, 9 nickels, and 75 pennies. How much money do we have in dollars? Well, we can convert that. We can make sure that we have every one of these in dollars. And we're going to use a very, very simple conversion chart. And I'm going to show you that conversion chart here in just a second. So I want you guys to go ahead and write this down. So you can see here that we're going to start with the 22 quarters. And from the quarters, we want to get rid of that. We don't want it to be in quarters. We want it to be in dollars instead. So what we have is that we know that 4 quarters is equal to $1. Okay? So in that instance, we can go ahead and cancel out the quarters. And then we're just going to multiply across. 22 times 1 is 22. 4 times nothing else is 4. So that's going to be equal to $5.50. And we're going to do that for every single one of the coins so that we know that there are 10 dimes in $1, there are 20 nickels in $1, and there are 100 pennies in $1. By knowing how much is in each one, by knowing how many coins is in a dollar, we can easily be able to convert from one to the other.
And this can be tricky, guys. So this is a perfect opportunity, like Mr. Wen said. If you're just unsure, if you don't get it, make sure you ask, okay? Send a Teams message, send a Schoology message. We are here for you guys. So reach out to us. Hey, Mr. Wen, Mrs. Becker, Mr. Ewald, I don't get that conversion thing. It's just not sitting well with me right now. Can we talk about it? Absolutely. Okay, so send those messages out. We're here to help.
Okay, so if there are any other questions, you want to make sure to send those messages our way. Make sure to turn in the questions by the end of your class period. So check Schoology on how to submit those. Check Schoology to see whether or not there's any other assignment. I know for me, we're going to have a metric system worksheet that's going to serve as independent practice. I believe that's the same for Mr. Ewald and Ms. Becker. Our next time-bound event will be either in small groups or individually, or talking with your teacher, making sure that you get with them about how that next time bound event works. Alrighty, guys, so thank you guys so much for being here this morning. I know that it's early, but we appreciate you guys, and we really like the participation.
Just want to make sure that the PowerPoint is posted for the kids to see in Schoology. A couple kids are saying that it was hard to see the numbers on the last one.
Okay, so thank you guys so much for letting us know that the numbers were hard to see. What we will do is make sure to change those numbers. Okay, number one. And then number two, we're going to also post this PowerPoint to Schoology as well. That way everyone has access to it. Everyone can look at it at their own time, and making sure that you're able to do those conversions. Okay.
We're good.
We're good.
Thank you, guys. Have a wonderful day. Reach out to your teachers if you have any questions at all. Enjoy the rest of your Tuesday, and we'll see you guys soon. All right, awesome.